If we're getting started with 1.02, there's two words that are really important for this section, and that's input and output. So input is what we're putting into the equation. So if I have f of x, that's how we read it, f of x equals 2x plus 4, and we want to input a number into the equation, our input goes here for whatever letter is right there. So it's x. So we're inputting into the equation. So I'm going to write over here input into equation. That's how I remember it. So wherever you see this letter here in the equation, you're going to input whatever number you're inputting. Okay, so if you're inputting 2, it would be 2 times 2 plus 4 if you're inputting 2. Output is the number outside of the equation. So if we're doing f of x equals 2x plus 4, our output is on the outside of the equation, which is over here. This is our output. So I'm going to write outside of the equation. At least that's how I remember it. So if I give you an output of 20, we would say 20 equals 2x plus 4, and then solve for x. Okay, so that's the difference between input and output. And actually, I'll leave my input up here where you can see it. Times 2 plus 4. Okay, those are the two big things you need to know for this section. So let's do a couple of examples. So example 1, I made it multiple choice, is if f of x equals 2x squared plus 4x plus 6 when evaluated gives a value of 22, what is the function's input value? So I need to know the input. What am I putting into the equation to be evaluated? This is another word for output. To get an output of 22. Okay, so if, in other words, I'm going to replace this with 22 equals 2x squared plus 4x plus 6. What is x? So let's say I use the input value. Let's try 0. So I'm going to input 0 in wherever I see an x. So let's see, let's do 22 equals 2. Instead of x squared, it's going to be 0 squared. Because we're testing this 0 over here to see if it works. So I'm just inputting a 0 wherever I see an x. So instead of 4x, I have 4 times 0 plus 6. Well, 0 squared is 0, so I have 2 times 0. 4 times 0 is 0, and then plus 6. 2 times 0 is 0, plus 0 plus 6 equals 6, but we really wanted it to equal 22. And 6 does not equal 22. So 0 doesn't work. I'm going to actually do this, well. So now let's try 1. So again, we're going to do 22 equals 2. Now I'm going to plug in 1 into these spots instead of 0. 2 times 1 squared plus 4 times 1 plus 6. And I want that right side to equal 22. So I'll write it this way. 22 equals, well, 1 squared is 1. So 1 squared is 1. Plus 4 times 1, which is 4, plus 6. Well, 2 times 1 Let me write this. 2 times 1 is 2. 2 plus 4 plus 6. So 22 equals 2 plus 4 is 6. 6 plus 6 is 12. And 22 does not equal 12. That's not correct. So we can also X out 1. And to make it smaller so I can do it over here. Okay, so let's try 2. That's our next one. 22 equals 2. Now I'm going to plug in 0 to these x's. Plus 4 times 2, because we're trying 2, plus 6. 22 equals, okay, 2 squared is 4. So I have 2 times 4, because you want to do that exponent first. 2 squared is 4. 4 times 2 is 8, and then plus 6. So 22 equals 2 times 4 is 8. And then we still have plus 8 plus 6. 22 equals, well, 8 plus 8 is 16. 16 plus 6 is, hey, 22. 22 does equal 22. That's true. So our answer is C. It's 2. Okay. All right, let's try another one. That's if you are given the input and you need to find the, it's if you're given the output and you need to find the input. So let's try example 2 because it's a little different. This one says, what is the output? So I want to find the output, this number here, of the function f of p equals 5p minus 3 when the input is 4. So my input is 4, so I'm going to input it into the equation. So I'm going to write f of p in green because I don't know what that is. Equals 5. Instead of p, I'm going to write 4. And this is 5 times p, so that's why we're doing 5 times 4. All right, 5 times 4 is 20. And 20 minus 3 is 17. So f of p equals 17. I can write it all the way down. So it's kind of easy when you're inputting it because you just have to simplify. When you have the output and you're finding the input, you have to solve for x or whatever variable. So do you see how these two were different? This one I knew the input and I had to find the output. But up here, I knew the output, I had to find the input. Okay, example 3 says the domain of the function f of x equals 2x cubed is 1 to 4. So domain is where it's going side to side. So domain on a graph means this way. We want to find the function's range. And range means how far up or down it goes on a graph. So how we're going to do this is we're going to just input both of these numbers into our equation. And that's going to give us our our range. So f of x equals 2x to the third exponent. So I'm going to input 1 first. So I'm going to input 1 in for x. So we can do f of x in green equals 2, but instead of x, I'm going to do 1 to the third power. And 1 to the third power just means 1 times 1 times 1. It's 1 multiplied by itself 3 times. 1 times 1 times 1 is 1. So I have 2 times 1, and 2 times 1 is 2. So that's our output for the first one. Now we're going to find our output if our input is 4. So we have f of x equals 2, but instead of x cubed or 1 cubed, we're going to do 4 cubed. And remember, 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And 2 times 64 is 128. So if we're looking at this function's graph, and I just want to look at the graph between 1 and 4, how high it would go would be between 2 and 128. That's our answer. So make